Network Reconnaissance, Part 1. In this nugget, we'll be discussing network reconnaissance, and this is Part 1, and we'll take a look at a lot of these things, at how we see TCP work normally, how we see ICMP work normally in ports, what they're all about. We'll take a look at a lot of these different factors so that we can understand later on how certain tools might be able to manipulate these things to work them to your advantage as a hacker, because most anybody can use these kinds of things that I'm about to show you here, but a hacker will use different methods for getting to a destination. So first, let's understand how the header is formed, as well as the three-way handshake, so we can establish communication between hosts, as well as how to properly end that communication. And there are other tools we use a little bit later on that will kind of abuse this whole process and get some useful information out of it that will help you to footprint a network. We'll also take a look at the ports that are used and what those are for. We'll take a look at ICMP, which is the Internet Control Messaging Protocol, and how it works. We can use a couple of tools that we have in most any operating system that are available to us. Traceroute, which is traceert in Windows, or fully spelled out as traceroute in Linux. We'll take a look at ping as well, and also a very handy utility called fping. Well, I gotta tell you, I don't think I've ever been so happy to start recording again in my whole life. You see, in the past week and a half or two, I've had to dig a 180-foot trench all the way around my house, and it's about 2 feet deep. And I was able to rent a machine for part of that, but there were certain places it couldn't reach, and then I ran into a boulder, which we get a lot here in Phoenix. And so it was a lot harder work than I planned on, and it was extremely difficult, physical, back-breaking work. And I'm doing that so I can add an addition onto the back of my house for my mother to live in, because she's starting to need some help in living right now. Well, you see, network reconnaissance is an awful lot like that. Well, no, you don't need to use a pickaxe for network recon. However, it does help to lay the groundwork for something that you're going to do here in the future. You see, without doing the necessary groundwork first with network reconnaissance, we can't perform a successful hack later on. Because network reconnaissance by itself, that's not hacking on its own. What we do with that is it helps us to identify viable targets so that we can have a more pointed and focused attack at a later point in time. And that really takes us right to our network reconnaissance objectives, which is where we want to find the live hosts on the network. That prevents us from wasting time going after hosts that don't exist. And once we find those hosts will have some ports that we might be able to exploit. So we'll find out which available ports are open, and we'll work with certain firewall rules, perhaps, that we'll have to get around as well to find those open ports. And we'll talk a little bit later on in our next nugget about scanning to be able to do some of those kinds of things. And then we'll take a look at what services are available on those destination machines as well. That might involve finding out what the operating system is on that destination, what services are associated with certain ports. Then we can find out maybe some weaknesses in those services or some exploits that we can run against those services. But a critical part of all of this is, first of all, understanding a little bit more about TCP packet structure. Now, before we get too far along, we ought to discuss a little bit about TCP packets here. And this is similar to what you would need to know about your transmission in your car. You need to kind of know how it works. You need to know how to shift the clutch if you got a manual transmission and some basics. But you don't need to know where every nut and bolt is in that transmission and what size all the gears are and exactly how many teeth are in each one of those gears. Well, similar to that with a TCP packet header, we're going to look at the most important parts of that as it relates to hacking. One of those would be the source port. When you send a packet to a destination, it's going to, on your end, create a randomly generated source port in most cases. And then what you want to really keep in mind here is the destination port. So, for example, if I'm trying to connect to an internet web browser or an internet web server on a destination, then those browsers are usually served out over HTTP, and it's going to be on port 80. So that's what my destination port is going to be for that. If I'm going to connect to an FTP server, it's going to be port 21. A lot of different network applications use different port numbers. And we'll talk a little bit more about those port numbers a little bit later on. Also, when we send out traffic over TCP, we have a sequence number. And this is to, when we send out that packet to the server responds and it increments that sequence number when it sends the data back to me. That way I can make sure that I haven't missed any data. So my data should go in the form of 1, 2, and if I all of a sudden see 4 in my next sequence number, then I know we're missing packet 3 somewhere, and a retransmission can take place. And usually it doesn't really start at 1, by the way, just FYI. It generates a random number, and then it increments from that random number. And then there's also kind of a corresponding acknowledgement number. Oh, that's one of the advantages of TCP as opposed to UDP. TCP has guaranteed delivery, and with the sequence numbers and the acknowledgement, it can confirm that the traffic was indeed received. There's also things such as the checksum. This is a simple mathematical calculation that's performed on the packet to make sure that the data has not been lost or corrupt anywhere. And then also over here we have window. This just identifies the size of the receiving window buffer for any of that incoming data. And then there's code, which on some diagrams will also be marked out here as flags. This is going to be of some more importance for us here as certified ethical hackers. This is going to identify markers such as SYN, ACK, and FIN. I'll talk more about those a little bit later on, but those are used, for example, in a three-way handshake or in a termination of a connection between two hosts. Urgent pointer is just that. It identifies this packet as urgent. Then you have options for just a number of different TCP options. You can also see sometimes a little bit of padding in there, and the reason for that would be to even out the size of the packet. In some network transmissions, it's best if all the packets that are going to be sent in a message are the same size, and so sometimes you can fill in a little bit with a little bit of padding there. And then, of course, you have your actual data. And then with UDP, we have some similarities here. We have a source port with UDP and a destination port, but we don't have this part in the middle, the sequence number, acknowledgement number, because UDP is a connectionless protocol. And of course, that simply means that if a packet gets dropped on the way to the destination would never know it, and the source would never know it. It just plain gets dropped. There are network applications or certain applications or other layer protocols that can take care of that for you, and that can confirm on their own whether or not the data has been sent or received. But otherwise, UDP by itself does not do that. That's another reason why, by the way, hackers have a tendency to like UDP packets, if at all possible, because they're easier to spoof since it's connectionless, and it doesn't have any handshaking, doesn't have any sequence numbers that you have to work around. Now let's also take a look at a very important part of hacking, and that's something called the TCP three-way handshake. Now, in normal TCP communications, this is what goes on between the client and the server. Well, first thing that happens here is that the client is going to go ahead from its source port, it's going to send a SYN set. And SYN is the term that's used to establish a new connection. So when I say SYN, I'm saying, hey, we've never talked before, but I'd like to go ahead and establish a connection with you. At the same time, the server then, when it receives this SYN set, it will say, oh, hey, I've got a new request for communication here. Hey, I'd like to talk to you too, and I acknowledge that I received your previous transmission. So that sends a packet back that way with both fields set for SYN and ACK. Then once the client sees this packet come back, it will send back to the server again, ACK set over here. And again, of course, the ACK there means that it acknowledges the transmission has been received. Now, the way this relates to hacking, because what we're seeing right here is just normal network traffic over TCP traffic. But the way this relates to hacking is that you can trick this stuff into doing other things. For example, what if I've never communicated with this server before, but I use a hacking tool to send out a SYN-ACK or some other flags that the server would not have expected to see? Well, when I do that and I send out strange flags to the server, depending upon which operating system is running and which patches, fixes, and updates have been applied, it will respond possibly in different ways. It may also respond differently depending on which applications are installed. So depending on the answer I get back, there are hackers' tools that can say, hey, based upon the way you answered me, I'm going to assume that you are a Linux server or that you are a Windows 2000 server. Now, there are ways of tricking us with that. For example, if the server has intrusion detection software of some kind, then what it can do is it can send back a cheater response. It can detect that, hey, someone's trying to fool me here. I'm going to send back a response that makes it think I'm a Linux server when indeed I'm actually a Windows 2000 server. And that's where you have to start to learn to read false positives, and you have to use other tests as well. This is just a preliminary step in trying to determine what is on that server and what it's running. And we'll use other methods a little bit later on to try to confirm. Now let's also take a look at how we would end this TCP session when the client is done receiving its data from the server. First thing it would do would be send out a FIN ACK. This is just a FIN flag, and this means that it wants to close the connection. And this is known as a gentle close. This is going to be a normal closing down of this session. You can contrast that with a reset, also known as a hard reset, and that would send a different flag. Instead, that would send an RST. And this is not really part of this diagram, so I'll kind of put that in parentheses so you know that. That's a hard reset. In our case, we're going to do a gentle close with a FIN ACK, and then the server will say, hey, I acknowledge that I received your FIN ACK, and I also want to close connection as well. So the server's sending back two packets here at once to the client, and the client will then say, okay, I acknowledge that you want to stop talking to me. I want to stop talking to you. That's it. It's final. It's kind of like a messy breakup or something like that. We're not talking to each other anymore. I mean, it kind of reminds me of my dating life back in college. The girl would say, I don't want to talk to you anymore. And I'd say, fine. In fact, I don't want to talk to you anymore either. And you know what? I was going to break up anyway. And she'd say, fine, whatever you want to tell yourself. Although, usually I didn't have this exchange. Usually it was just, I got the hard reset. All right, let's move on to ports. I mentioned ports a little bit in the past. Let's get into a little bit more detail about that. Recall that TCP and UDP require a port number to connect to certain kinds of service. So, for example, if I'm running Windows XP and I want to connect to a terminal server in my workplace, then I can use port 3389 to make that connection. If you use FTP, then you probably connect over port 21 for FTP connections. So that's why we use these ports, because they're typically associated with some kind of service on the destination that we want to make a connection to. Your port numbers are 0 through 65,535. We don't really ever use 0. But the first numbered ports here, 1 through 1,024, these are known as our privileged ports, and they're more well-known than some of our other ports. They're also known as just that, well-known ports. For example, 21, like I said, FTP. 80, you probably know what 80 is. That's what you use to connect a web browser to a web server. And then, of course, there are other ports as well. Anything greater than 1024 is also known as your higher ports, your ephemeral ports. And those have often been considered in the past to be open ports, but in reality, a lot of different vendors and applications have kind of reserved certain ones, such as Microsoft reserving 3389 for the remote desktop or terminal server connections. One thing you should be aware of is some of the more commonly used port numbers, and you should also know what some of the other ones are for your likely targets. So, for example, if you're sniffing network traffic at your target network, then you'll want to see what kind of port numbers are passing back and forth. That might help you to identify what kind of services are being run on that network. Now, you'll learn a lot of these ports and what their number assignments are as you go, but one other thing you could do is to look up certain port listings and what they're commonly used for. One place I like to go is PortsDB. Now, this is a website that's actually kind of offline right now. It's undergoing maintenance. But if you go to www.portsdb.org, you'll see a really good listing here on their webpage of all the various ports. You can also just go to this services file for the time being. Hopefully it's up by the time you look at it. But the services file here shows you what a lot of the commonly used ports are. For example, here's our TCP that we were looking at earlier, rather our FTP we were looking at earlier. There's TCP for file transfer data, which is over port 20, and then the control data takes place over 21. UDP is in here somewhere for UDP 53, that's for DNS queries. TCP 53 is used for zone transfers. And we see that down in here, DNS queries right here. We also have, all these different kinds of things, and you just want to scan through this every now and then to look at some of the more commonly used port numbers. And then also, again, like I said earlier, when you're sniffing network traffic, if you see something all of a sudden that shows up on, TCP94, then you know there that they're probably using some form of Tivoli there for their network management. And so then you would just go ahead and search for any known vulnerabilities against Tivoli and see if you can exploit something there. There's also a kind of an interesting one. If you look for Doom in this file, you'll see that the makers of Doom, which is id Software, that PC game called Doom, they've reserved port 666 for their LAN games. That's kind of interesting. In any case, there's a lot of these different ones you can look at and a lot of ones you can research. Now, there's also ICMP, or the Internet Control Messaging Protocol, which is an extension of the IP protocol. It's also connectionless, just like UDP, but don't take that to mean that you have a very, very unreliable way of using ICMP here, because a lot of times ICMP will attempt to contact its host multiple times. Examples of that would be with the ping command, which is what we probably most commonly use ICMP for. Ping, as you may already know, is what we can use to test out whether a destination host is up and available. Now, it doesn't always work because firewalls many times will block the ping command. But at least if I'm trying to find, my own mail server in my own corporation, I'll try to ping it because I'm not getting my mail. I want to see if it's up and alive. Well, even though it's connectionless, the ping packet under Windows is going to be sent 4 times. Under Linux, it's going to be sent constantly until you interrupt it, unless you specify a specific parameter. A similar thing happens with the traceroute command. Traceroute is what we can use to track from the host source to the destination, and we can see how many routers or how many hops it goes through. It also uses ICMP, and it doesn't use just one attempt. It attempts multiple attempts to get to that destination. So it's okay that it's connectionless in that respect. Another good use for ICMP is the error control that we get out of it, because it can return error messages. That's one of the purposes for ICMP, is so that it can give you error messages, control, or informational messages. And so things like the traceroute command that I just mentioned is what we can use to find the routes from the source to the destination. Now, one thing to keep in mind also is that a lot of times ICMP will be blocked, not typically on public internet routers or servers or DNS servers, things like that, but usually on corporate networks. So, for example, if there's a firewall in front of a corporate network, and there just about always should be, then it's probably going to be blocking ICMP packets, or there's a router rule of some kind that will not allow ICMP packets. So a lot of times the traceroute command will only get you as far as the front door, but you can't get any further than that into the network. So as an example of using ICMP, let me just open up a command prompt, and I'll do a traceroute to someplace we know. How about traceroute to www.google.com? And we'll press enter. Now this could take a little bit of time to get all the results, but what it does is it sends ICMP packets and it goes through each hop along the way, and at each hop it decrements one. And that's how it's able to keep track of this information to determine the appropriate hop count in between. And like I mentioned earlier, even though ICMP is an unreliable protocol in terms of the fact that it's connectionless, it does it 3 different times, so if one of these got dropped, it would at least continue on and try the other 2. If you do get stars in here, by the way, or asterisks in this traceroute command, that would indicate that it was not able to get a response from that particular hop or something timed out. Now, another command you could use would be the path ping command, and I've just went ahead and typed it in here, path ping www.google.com. This is just a Windows-only command, and what it does is notice that it doesn't give me the milliseconds for each one of these in more detail up here. It just goes through all of the results, and then it calculates statistics for the entire time. And although I'm not going to go into more detail with this right now, and it takes a little while for it to generate its results, if you really need to get nitty-gritty information, this will usually give you a little bit more accurate information than just a traceroute. Now, if you're in Linux, then what you could do is to not use traceroute with trace RT, which is how we spelled it in Windows, TRACERT. But instead, what we would do is type in the whole word, trace route, and then you type in the destination. And then it seems to work a lot faster, as you can see here, than the traceroute command does from within Windows. So in any case, that gives you an idea of how to use those traceroute and path ping commands. Now, notice that here with this one, where I went to google.com, it had multiple addresses that it warned me about, but it was using 64.233.161.147 as the address that it was trying to reach. And so it went over 30 hops maximum, and it did a kind of a similar thing here. But notice that it never actually got to the destination. This could be an indication that Google is blocking my access to that specific server, and it's likely, again, that they have some kind of a firewall rule that prevents me from accessing it directly. Now, how does this relate to hacking, by the way? Well, a lot of times hackers, and this goes beyond the scope of certified ethical hacking because we don't deal much with hacking into routers very much, but if you're able to compromise a router, maybe you want to put a denial of service attack against it, or you're trying to flood it somehow, then you can keep using the traceroute command to see if these milliseconds keep slowing down and taking longer and longer and longer, or if they start to star out on you, which means that they've timed out and it's no longer able to respond due to a denial of service attack. Now also we can use the ping command, which I've mentioned in the past. And for here, for example, I want to ping a server or a Windows 64-bit client that I can't actually remember if I turned it on or not, so I want to see if it's there. win64.accusource.local. And so if I have a DNS server that's able to resolve that, then we'll see if we can get a response. And I'll also find out, by the way, of course, its IP address if it is up and running. So I'll type all of that in. And before I press enter, let me point out, why do I use .local here? Well, that's just it's something of a tip, and there are ways around this, but for security measures, I can prevent myself from being attacked by name resolution over the internet because internet DNS servers don't have a top-level domain for .local. Of course, they have .net, .com, .org, and all the rest, but there is no .local, so no one could resolve to me directly, at least. Other ways of finding out my IP address, then I'd have to worry about somebody attacking me through a direct IP address. But at least they can't using DNS. So in any case, I'll go ahead and press enter here, and I'm getting answers back. Now, like I said before, with Linux boxes, it's going to continue to ping that host until you just stop it. So I'm going to control C there to just stop it manually. Otherwise, you can use a parameter to stop it. Here, for example, I'm going to ping that same host, but I'm doing a -C, which is for count, and then the number 4. So I'm going to tell it to count to stop after a count of 4, and then it will terminate after that. Now, let's go back to the ping command on a Windows box. And again, the ping command might be useful for identifying hosts that are up and alive on the network. It's more useful if you're inside the network. For example, if you're doing a white box or gray box attack from within that corporate's network. Not as useful if you're outside, for example, on the internet trying to get into a corporation, unless you want to identify where their routers are, or at least the ones that are internet facing, for example. So in any case, let's go ahead and take a look here. And I want to just ping certain hosts. Maybe I want to see if 10.10.10.1 is available. And I'm getting answers back. Now, here's one thing to keep in mind when you get replies here, especially with these kind of .1s or the lower number IP addresses. Frequently, corporations will use the lower numbers or the higher numbers for routers and that type of network equipment. So this, in my case, is actually my router. How about 10.10.10.2? And I'm getting replies back from that one. How about another one? Let's go up to 10.3 or 10. Let's go to .4. Oh, I'm not getting answers from that one. By the way, I'm using a Class C subnet mask, so I've got 24-bit subnet mask, which gives me 254 usable addresses here. So it's only going to take a little while for me to get through all 254 addresses. Please just be patient with me here. No, actually, I'm not going to do it that way. I'm going to show you a shortcut here instead to be able to ping multiple hosts at one time. Let's go ahead and show you something else before I get to that, however. If I do a ping-5, notice that I'm getting results. What if I want to say, I wonder what that computer is. Is that just another Windows XP client on the network? What kind of function does it have? Well, there are other ways of doing a little bit more network discovery to find out what those are, especially if you're using more sophisticated tools. But just for a real quick access to it, I might do a ping lowercase a. It cannot be an uppercase, even in Windows, which is typically not case sensitive, but here it is. Anyway, ping lowercase a followed by the IP address. That will return the name of that host to me if there's a reverse lookup zone in DNS for that host. And in this case, there is. Here it says it's DC1. So what does that tell me? Well, maybe DC means domain controller. I might also get an answer back that says MX, which is usually a mail server, or mail.actsource.local or something like that. So in any case, that's a basic functionality if I would use the ping command to find our hosts. But we can't really do this through 254 addresses, and in large corporations you can have thousands to go through. No way in the world do you ping each one. So instead what you can do is to use another tool called fping, and this will save you a ton of time. And for this, I've created a directory called fping, and you can just download this, from a number of different sites on the internet. Just Google for it. But I'll just change to, I think I called it fping. Oh, yeah, there it did. And I'll just do a dir here to show you the files that I've got in this. There's our main executable, fping.exe, but it really works best if you've got an output file of some kind of plain text file that has a listing of IP addresses in it. And what I like to do a lot of times is to use Excel, and if I know the ranges of IP addresses that I need, I'll just type in the first couple of addresses in a column, and then I'll select both of those addresses, and then use the autofill handle to drag down through, and it automatically fills in sequentially all the remaining addresses, and you can go just about as far as you want to go for as long as you can hold the mouse down and drag. So you could do it that way. Another thing you could do would be to use something like this, ipads.bat, and you could just copy the lines out of this if you want. It's real simple, ipads.bat. And I didn't mean to do that right then. I meant to say type ipads.bat. Anyway, at least it did when I wanted it to. But this is what it does. It's just echo off. And then what it does is it uses an old DOS command called for. What this does is it allows us to use loop commands to be able to perform multiple things at a time. So what it's going to do in this case is it's going to increment in steps of one sequentially added addresses for us, and it's going to go all the way up to 254. It's going to output these addresses in a file called ipads.txt, and if there's any errors, it's going to give me ipads.log. So if I want this batch file to spit out a whole sequence of 254 Class C addresses, what I'd do in this case is ipads.bat followed by the range of addresses I want. Now, if you have another private IP address range, you might be using 192.168. something or another. In my case, I'm just using this one. So I'll press Enter here, and then we'll see what it spit out for me. I'm just going to actually go through the browser, Internet Explorer, to be able to find this. So we'll go here, go to fping, see its ipads.txt document, and we can see here that it spit out all those addresses for me. Okay, so real easy way to go with this. Now I've got them all. There were no errors in this, so my error log is empty. Now let's go ahead and use this command. I'm going to use the fping command along with the file that it created, which was ipads.txt. So here what I'm going to do is to fping-f. That tells that I'm looking for a file, and then I identify that file, ipads.txt. And then it goes ahead and does its thing. It's going to ping a whole bunch of different hosts at a time and tell me which ones are alive and which ones aren't. Now this does take a little bit of time, so I'll pause recording and come back to you when it's done. Now we can see here that there were a lot of these that were unreachable, so we went through quite a few of them. And by the way, I paused recording, but once it gets to the unreachable ones, for some reason it goes really, really fast and just scrolls the rest of those really quickly. But it does show me at the top of this list which ones were alive. Now, if you don't want to see all of that, you can also use another parameter in this that will only show you the alive ones and won't waste your time with showing you all the unreachable ones. And honestly, I couldn't remember what the option was, so I did an fping question mark, and it shows you all the options here, but it was -A. So I could do the same kind of thing and only show me the alive hosts, for example, -F, and then I actually can put a -A at the end here, and press enter. And then it would only show me the alive ones, not show me the unreachable ones. Another thing we could do with this, by the way, would be to output the whole thing into a file. And this is just about to finish, so I'll go ahead and do that here as well. In order to do that, I'll just simply follow it with a greater than, and then the name of the file I want to dump it out to. So I'll just say, alive.txt, and press enter. And then what will happen is it's going to go ahead and put it into a file called alive.txt. This could be very useful, for example, if I then want to use that text file with other hackers' tools that will be able to search against that file to only query against those alive hosts, so that once again I don't waste my time with dead hosts. So let's go ahead and take a look at those, and we'll go back to Internet Explorer. Actually, I called this Internet Explorer earlier, didn't I? This is Windows Explorer, and here's my alive.txt file, and there it is. It shows me only the alive hosts, and I can then go ahead and probably use that with other hackers' tools as I want. Now, it's at this time, especially when we're using something like ping or fping, that it probably comes in handy for me to explain again what we're really doing here. Remember, there's two kinds of things you can do as a certified ethical hacker. You can do a vulnerability test, or you can do a pen test or a penetration test. A penetration test, the key there will be stealth. If there's an intrusion detection software on my network and it's identifying that I'm sending out a whole bunch of pings to all the hosts on the network, it might just stop me. It might just shut down my IP address or close my port or something like that and prevent me from doing anything else. So with a pen test, I might not want to use fping because it's a little too aggressive that way. However, with a vulnerability test, that might be something that I would do as the IT administrator of my own network. I don't care if I get caught, because who would